Okay, angle between two lines in two-dimensional space. So we have our vector equation of two lines. Okay, we know that line number 1 goes through this point here, and this is a directional vector. Line 2 goes through this point, has this as a directional vector. Now, they could lie anywhere in this space here. We're not sure exactly what the slopes are. And we actually have to find where they intersect each other and what angle they make. That can be very difficult. They may not intersect till, if we were to actually draw it all out, maybe some number way up here or way down here. So instead of actually drawing out the two lines, figuring out where they intersect, we're going to focus on the directional vectors. Because the directional vectors, if we just figure out where they intercept, does anyone know where these two directional vectors are going to intercept? What point will they both touch? Directional vectors. Where do they come from? The origin. So because they both come from the origin, that means they're both going to intersect at the origin if we just talk about that. And it doesn't matter, any magnitude of those directional vectors will still cause the same angle with each other. So our S is -1 and 3. We'll call that roughly vector S. And our T, or we'll call it, sorry, vector L. And vector L2 is at 3 and 4. Sure. Okay. So they form some angle. Okay, we'll call it theta. We need to figure out what that angle is. Well, now what we've done is we've actually given these vectors, and we'll call them, let's call them O for the origin, OA, and OB. If you guys remember, in order to find an angle, we can use our dot product. In fact, let's call this vector A and vector B. And the dot product of vector A dot vector B is equal to the magnitude of vector A times the magnitude of vector B cos theta. Okay. Now we're actually trying to figure out theta here. So we're going to rearrange this equation before we even put numbers into it. We know that cos theta is equal to vector A dot vector B divided by the magnitude of A and B. And essentially, theta will be equal to cos inverse of that. In brackets, A dot B divided by absolute value of A, absolute value of B. Okay? So, since we have that information, the vectors on top, vector A and B, are talking about the component parts. So we're going to get theta is equal to the component parts of the directional vectors. Well, vector A was our -1, 3. So -1 dot, 3 dot 3 over 4. And then we have to divide by the magnitude. Don't forget this is all cos inverse. Sorry. The magnitude of A. Well, the magnitude of A is where we take those 2 points, square them, and square root them. So if you remember, that's going to be the square root of -1 squared plus 3 squared, and multiplied by the square root of 3 squared plus 4 squared. Okay. Our dot product on top is going to give us -1 times 3, which is -3, plus 3 times 4 is 12. Divided by -1 squared is 1, 9, 10, root 10, times 9 and 16, root 25, which is 5. We'll write it out as root 25 anyways. Is that right? 16, 9? Yep. So we end up with 9 over 5 root 10. All, sorry, I should be writing this. Inverse cos. Inverse cos. So we're going to put that into our calculator. 10 root, oh actually, can I do this another way? 9 divided by, no, I don't think my calculator can do it in one step. We're going to have to do it in two. So 10, root of 10 times 5, 15.811. So 9 divided by 15.811 equals, and then second function cos, to figure out the angle, 55.5 or 0.3 degrees. So all we did is reverse our equation we learned last chapter, where our dot product of A and B.